So this video is going to be going into the ones that are a little bit harder from the textbook. So these ones are going to be problems from 3.4.1. These are not necessarily always longer than the proofs in the other videos, but they are a little bit sometimes less clear, or they may require you to do some steps that initially you might feel uncomfortable doing. So let's go ahead and run through 3 in this video. We're going to be doing A, B, and D. So with A, we have the following. That should take about 7 lines. We start off with, let's start with just writing out our entire argument here. So the thing to note here is we're going from this type of claim where it's a universal that goes over an arrow to a claim where the arrow is the main operator and we have 2 universal claims on either side. So you could do a reductio with this, or you could do a CP. I'm going to do a CP, mostly because it's shorter. So now let's go in and write down our premises, and I'm going to shift everything down a line. We only have one premise, and it is this. So let's go ahead and start a conditional proof. And from here, since we have 2 universals, we're just going to be able to use UE on both of them. Let's start with line 1, and then line 2. Then we can do modus tollens. And then before I finish the next one, let's go ahead and fill in the assumption numbers. So we have a 1, we have a 2. That's a 1, that's a 2. This is from 1 and 2. The next step that we're going to do here is actually going to be to use UI to make this universal X negation Fx. Now, an initial concern might be that we're going from a particular to a universal claim, but let's double check. Are we allowed to do UI? To figure that out, we need to look at those assumption numbers. We look at the lines where those are the assumption numbers, and we ask, do we have a little a? If the answer is no, we're allowed to use UI. If the answer is yes, we are not allowed to use UI. Here we see that there's no little a to be found. It's all x's. As such, we are going to be fine to do a UI here. So we write down 5 in UI. My thing is frozen. 1 sec. There we go, now it should be back. And we would write down a 1 and 2 over here. Now that we've gotten to the conclusion that we were aiming for with our conditional proof, we're able to go back and close out the conditional proof. So we write down we assumed all of x negation gx, and we were able to reach x negation fx from lines 2 to line 6 conditional proof. Write down a 1 and a 2, and cross out the 2. Something to quickly note here. When we went from negation fa, we went to universal x negation fx. Notice that that negation stayed on the right side of our universal claim. You cannot go to negation x fx. This is wrong. Don't do it. So let's go ahead and do B. B says, the following. So this is, again, something where we can probably do a conditional proof with it. And I would recommend a conditional proof. You could try doing something else, but it would take a little bit longer. Start for our first premise. Start our conditional proof. It's just freezing up a bit today. And then since we have an existential claim in line 2, we're going to start another proof and assume it for the sake of EE. In this line now, we're going to be able to use UE on line 1. And that'll get us negation FA from 3, 4, MTT. From there, we're going to be able to say, therefore, there exists an x such that, not fx. From 5, this is going to be EI. And we can always use EI anytime we want, so that's a perfectly fine move. Since we've managed to get from where we started to our goal, we need to end up discharging out of our EE line here. So in order to do that, we're going to hop back into the last line of the argument. We're going to write down what we've already written. Then we cite line 2, line 3, and line 6 and write down EE. Then we're going to be able to discharge out for our conditional proof. We've shown that exist x negation gx leads to exist x negation fx. 2, 7, conditional proof. Then we can go back and fill in our assumption numbers. 1, 2, and 3. 1, 1 and 3, 1 and 3. This is a 1, a 2, and a 3, and you discharge the 3. 1 and a 2, discharge the 2, and we end up with just assumption number 1 left alive, which is as it should be. So let's go ahead and quickly do D. D is biconditional, or not biconditional, it's bidirectional. So D is for all of x, negation fx, is able to derive and be derived by not ex fx. So let's do direction 1. This should take about 9 lines. So let's start for our first assumption, and in this fact our only assumption. That's an assumption. Then we're going to start a reductio by assuming the opposite of our conclusion. Then we need to start an EE. Then we can go to negation FA using UE with 1. Then we put those two things together. And introduction. And this is where a number of folks will make a mistake. They'll try to discharge the reductio in favor of 2 because we've reached a contradiction. But we can't do that, and here's why. Let's take a look at the assumption numbers. This is a 1, that's a 2, that's a 3, that's a 1, and this is a 1 and a 3. Right now, number 2 isn't, or like line 2 isn't playing any causal role in reaching this contradiction down here. So we can't discharge line 2 at all. What's playing a causal role is the first assumption and the third assumption. However, if we try to discharge line 3 and just say, hey, we've therefore proven not FA, that's not going to actually really get us anywhere. Because if we were to do that, so let me show you what not to do. I'm going to show you it in blue for a second. So if we were to try to discharge this in favor of not FA and say that this shows that the thing that we ended up doing in line 3 was incorrect, Well, one, we still have to close out the EE. So then we'd have to somehow say not FA, and we're not allowed to do that because we can't get a little letter A going from an EE. So the only other option really is to discharge line 1. And that's what we're going to do. We're going to say it follows that not the case universal X, not FX, from 1 and 5 RAA. And then you discharge the 1 right here. But this isn't discharging it for good, because notice that we're still within the EE line of the argument here. To get out of the EE line, now we hop back, we reiterate what we just wrote, and we write down 2, 3, 6, EE. And I wrote it the wrong way. Because that's going to get us out of our EE box at least. And it lets us discharge a 3. And notice that the 1 is finally back. And that's good. And let me double check. 2, 3, 6. Actually, the 1's not back yet. I take it back. The 2 is back. So from here, now we're going to be able to get another contradiction. We're going to put lines 1 and line 7 together. And now we've shown, because when we put in the stuff over here, now we're able to show that 2 leads to a contradiction. So we're able to go back to 2, and we're able to discharge 2, and say that's not the case, the EX, FX, and that's due to 2 and 8 RAA. Then we write down a 1 and 2, and discharge the 2. So this is how to do direction 1. For direction 2, it's a little bit quicker. Only 6 lines or so. You start with the negation of fx. That's an assumption. And then we're going to assume a particular. We're going to assume fa for our reductio. And remember, our goal here is universal x, not fx. So this could also be read as for all of x, it is not fx. So the opposite of this is saying that there is something that is f. So that's why we end up assuming a particular fa. And then from this, we're going to be able to use ei. So then we say that there exists an x such that fx from 2 using ei and this will let us get a contradiction. We have existential x fx and not existential x fx. From 1, 3, and introduction. Since we've shown that 2 has led to a contradiction, we're able to hop back out and we're able to say not fa from 2, 4, RAA. And before I do the last step, let's write down the assumption number so I can show you something. So that's a 1, that's a 2, that's a 2, that's a 1 and a 2, and then here it's a 1 and a 2, but we discharge the 2. Because our goal is to have a universal statement. So that means that we need to actually at the end do a UI to turn negation fa into universal x negation fx, and that would be 5 UI. But the question is, are we allowed to do a UI? Because this might look like we're going from a particular to universal claim. But here's why we're not. In order to see if we can use UI, we have to look at our assumptions and ask, is there a little a in any of the given assumptions that we're pulling from? Here, we're actually only pulling from assumption 1, because assumption 2 has been discharged. It's as if it doesn't exist. And up here in assumption 1, there is no little a, which means we are allowed to use UI here to go from negation fa to for all of x not fx. And the only assumption that we write down over here is a 1. So this is a completely valid move. And in fact, this is how you do direction 2 of part D.